mobile, ubiquitous learning, inquiry-based science teaching. Maybe it seems to be a little bit complex, but it's not the case. Okay, the outline of the talk, I have too much slides, okay? But it doesn't matter because I choose some of them and I use almost slides, of course. Okay, the main contributors of what I explained today is Jean-Marie Gillot from Telecom Bretagne, and you can ask, I don't know if in French, don't worry. This. Okay. No. Yeah, I need to train again. Koen van Lindgren was a PhD in lab, and Sylvain Louis is a teacher in the university, he's a teacher in physics and a specialist of didactic physics. And Ahmed Bouzrou is a colleague in Telecom Sud Paris. And okay, what is inquiry-based science teaching? The idea is that when you want to teach science, you are using problem-based learning activities, and these problem-based learning activities have to be adopted. That is to say, you take real problems which are ill-defined. That is to say, you have several solutions, not just one, but you have to argue for your solution among one, among at least two, okay, or three solutions. And you need to involve practical experience, which is very interesting, and also searching for information to solve your problem. And the idea is that you don't force a student to have specific learning activities or sequences. They have to organize their learning activities and distribute learning activities among them. And they also have to argue with other. Okay. And of course, to teach in this way, you have to define relevant problems and relevant scenarios according to what you want to do. And the idea is to use technology and enhanced learning system to foster such type of activity. And the idea is to use ubiquitous computer system and social also system. The idea is to integrate social media application here called personal learning environment, to say a set of Web 2.0 tools, in fact, and to combine that with mobile and ubiquitous computing. And the idea is to increase the constructive learning process in IBST. Okay? This is the definition of that. Okay. And the idea is that by means of using a set of Web 2.0 tools, you are able to provide spaces for collaborative knowledge building, collaborative information building among a group of your students. There are also the possibility to define self-regulated learning sequences and communication with peers, reflective practices, also to have feedback according to what they did. And what can we obtain from mobile learning? The idea is that by means of mobile learning, you can have learning activity which can occur in location, time, which are significant and relevant for learners, which is very interesting. To say, you can do specific activities in real context, in relevant context, and that you are only able to do without mobile devices, in fact. Okay? Not only mobile devices, but also connection to the internet. Because if you have connection to internet, you are able to use Web 2.0 tools, you are able to communicate everywhere, at any time, any place. Okay? And you can do it in real time, which is very interesting. And the main difference between, at an abstract level, of course, mobile learning and ubiquitous learning, the idea is that in ubiquitous or pervasive learning, you are able to capture the context The context could be the location, could be the location of the different people in the groups. It could be also the time. It could be lots of different features. By means of these features, of course, you have situated learning activities, but the main point is that you are able to filter information to be able to give the right information to the right person, to the right group at the right time. Okay? That's the main point. Okay. If you think that you have lots of different Web 2.0 tools, okay, and the main problem is that if you want to provide relevant information to the different students and also to the tutors, then you have to retrieve information maybe in WordPress, in Migo, in Facebook, Skype, in Drupal, and so on. But the main problem and the main drawback is that these tools are data sealed. That is to say, you are able to search in these tools, but you are unable to search and to reuse automatically by means of the computer-based tool this information. Then how could we deal with that? Is it possible to have a precise search engine to manage context awareness, adaptation, seamless learning? Because you need to have two things. A very precise search engine to be able to retrieve the relevant information and sufficiently precise to make context awareness and also adaptation. Okay? Then if you are using Google, you have here the size of the okay. Sorry. Yes, like this. Okay, the size of the brain and intelligence of Google here. Okay? Just a joke, of course. And then we need something which is intelligent Google. We have much more brain here. And, wow, but, yes. I'm afraid that I delayed, the slide, sorry. But I can't speak about that. The idea is to use semantic web and link data to be able to retrieve the information, because now, if you think about maybe WordPress, it's possible to install a plugin in WordPress with which you can extract almost all the content in the database according to some standard lightweight ontology. That is to say, you get the triples in RDF, and you can put that in the triple store, and you retrieve the data. Okay? And just one example, current IBST is for historical based science teaching. The idea is to use historical technical tools, okay, for teaching. And the problem is divided into three parts, but I'm just interested here in the first part. The idea is to go in the hardware and to understand what happened in the past and how is the support now. And just to explain, if you look at this, you have here the actual bridge, okay, in Brest. Here you have the previous bridge, and you can see before the end of the World War, the Second World War, because this is I have okay, here another picture, okay? This is a swinging bridge, and here you can put something just with two persons, and you can swing the bridge. It's an incredible mechanism, just a gearbox, okay? A very simple, to some extent, gearbox. But it's very easy to understand, It's easier to understand for students, because the mechanism is simple. And they also have to understand lots of things about where was the bridge in the past, why the bridge was built, and all the different economic issues and different issues in the past. And okay, most of the time, such type of high IBST scenarios are like this. You have students are in small groups, okay, 7, 8, and they have to activate prior knowledge, that is to say they read the problem, and they have to understand the problem and to understand what kind of knowledge they have now, and what kind of knowledge they have to acquire. And for that, they need to retrieve information, and they define collaborative and cooperative activities, because the group could be divided into subgroups, okay, to find some pieces of information. And after that, they have to collaborate and to exploit what they retrieve. They have to write a report, and at the end they have discussions, and the tutor have to give them, to some extent, the right answer, something like this. But how they do it now? They have digital camera, and they have to take pictures of the landscape. And I'll show you just after that a picture. And they have to locate the different elements of the past in the current harbor. Okay? And they have also a small map of the harbor. And they have to identify the traces, in fact, of the old bridge. And if I look at that one, okay, if you look here, there is a trace of the old swinging bridge, okay, on which you have put the half of the bridge and you can turn left-right, okay, and they have to identify that and to understand how the port was in the past. Of course, now it's also possible, it's out of my thought, but it's also possible to have this toy, or to have a smartphone, and to have reality, augmented reality. That is to say, you can see when you look at the landscape, you can see the port before, you can see maybe the swinging bridge mechanism in 3D, okay, and you can see how it works. It works in the past, and it could be very nice. Okay, and now, what we can do with social media tools and ubiquitous computing. Here I just show some modification to these two phases, the phase 3 and the phase 4. The idea is that students have smartphones, tablets, camera, GPS, network access, and these tools. And we divide the different groups in subgroups, okay? One visits the harbor, another one is going to the Navy Museum, which is close to the harbor, in order to seek information, and also another group in the local public records. The idea is that the students have to distribute the learning activities into the subgroups, and they have to find some specific information in the Navy Museum, local public records, and also in the ports. And the idea is to provide specific services to the students in order to coordinate the different activities. That is to say, to provide services for retrieving information or to push information to the students. Okay? The idea is that you could maybe search for information about the swinging bridge in the Navy Museum, and you find something else which is not expected. Then you can send information to the other subgroups, or you can push information to the other subgroups to tell them, okay, there are new information here, and then they can change the activities, the information seeking, and so on, and in real time. Okay? And they can also, of course, collaborate and communicate to synchronize what kind of information they retrieve, and maybe they need to retrieve more information or another type of information. And it's also a way for the tutor to look at what happens in the group, the subgroups, and to be sure that maybe the group didn't miss the the traces of the swinging bridge. Okay, the tutor can do it, but you can also have specific services dedicated to that. That is to say, after maybe 45 minutes, you observe that there is no data, nothing, no annotation about the data and the traces of the swinging bridge. Then you can ask questions to students to tell them, okay, maybe you missed something, where are you, and so on. Okay? We can imagine lots of different things, but here it's just some possibilities in the slides, and we discuss these possibilities with the tutors. And okay, I'll say most of the things. You go from the push mode, you can recommend information from the name, museum, or local public records from which it was also do. Can provide information for some group visiting the board to other subgroups. And I think that I tell you most of these things. And of course, it's possible to provide query in the pull mode, query filters, concept, resources, activities in person according to the situation. Okay, according to the context. And then, okay, I talked a little bit about Snoop, which the last acronym we use is Moodle. Semantic, Massive, Open, Online, Parallel Learning Environment. Ah, wow. Okay. Okay, of course, we need ontologies. That is to say, we need to have common vocabularies with which we are able to exchange information across the different Web 2.0 tools. And we need a domain model. Now we define a very simple domain model, and we use it in a very simple way, because as soon as a student has tagged a content with keywords similar to the name of the concept, we consider that it is a concept. It is the first step. Okay? But we also keep all tags, and we can manage tags. And we define a context model, but which is just a simple one, for instance, in the prototype. Okay? And we didn't have spend sufficient time to think about what kind of feature we could have in a social network and Web 2.0 tools for the social network which are relevant for managing the context. Okay? And of course adaptations. And we have also a simple resource model, and we didn't work on the recommendation model. The idea is to have a recommendation model at the end. Okay, sorry, I missed something. Okay, I missed that. In the context model, of course, we have at least a user model, and we have an activity model. Okay, the idea is that the user model is very common. Okay, all adaptive systems we have a user model. Okay, in the past, we used to have a task model, hierarchical task model, with which we define context-aware scenarios, and these scenarios with strong scenarios. Okay, now the idea is to leave students freedom to define activities as they want, and to distribute activities among them as they want. But of course, as this type of scenarios are always the same, we have kind of meta-activities which are always the same. Then the idea is that it's a kind of guide for students to define and distribute activities among them, and introducing in the activity model what kind of learning activities they want to do. Of course, you can choose all of them or not. Okay? Behind that, the idea is that, in terms of context, it's my strong viewpoint. It is the most important point is the activity. Of course, this activity is taking place in a community of persons with some rules. Okay, if you think about activity theory, something similar. Okay? But if you define the activity, you are able to say, to know most of things about what the students are doing. Then you can filter information more accurately. Is the idea why we have an activity model. But also because okay, it is interesting for that, but it's not only because it is interesting. It's also because when we discuss with colleagues who are teachers in physics, that effectively these scenarios are stable in time at this abstract level, of course. And here it's just a way to show you some specific things. That is to say, if you are using, okay, we can't only use strong ontology in some way, huge ontologies and so on. Then we want to use sometimes to have something, to have ontologies, lightweight ontologies, and to have also something with which we are able to pass from type, taxonomy, to ontology. Okay? Then there are some ontologies that, like Scott and MOAT, which are made for that. But we just look a little bit about this, but we didn't manage that now. Okay? We define kind of domain model like this, but it's not just the first step. And if you look at this schema, you have here, you have type, and you have topic, and you have topic coming from here, SIOC, which is semantically interlinked online communities, which is a lightweight ontology about social web. And the second one is FOF, friend of friend. I don't know if you are aware of these ontologies, but they are, it's very easy to transform the content of database of social media tools to have triples in using these ontologies because they were designed for that. And it could be we can do it automatically, which is very nice. And yes, it is the main point to keep here. And also the notion of groups, of course, and user account, because you can have one person having different user account in different Web 2.0 and by means of these ontologies, we are able to establish a relationship between this different account and this user. And then we can retrieve all information provided by this user or all comments provided by this user. Okay, the second one is here the user model, and here the same interesting point is also the same. That is to say, the relationship between the user model and this specific ontologies SCOC and FOAF. Okay, and here you have the set of meta activities we called in the ontology, and all these activities are in fact subclasses of an ontology called online presence ontology, in which you have specific concept which is actions, and activity is a subclass of action. Okay, and I told just a little bit before. That is to say, we can acquire on the fly the different metadata about the content provided by the user automatically by sending queries to the database of the Web 2.0. Okay, and the idea that we have a set of Web 2.0 tools. We have widget for interaction human interface, and we have semantic web services based on Java tools. Okay, and also database in which we store all triples. And now The idea here is to, it is my homepage on NetVive, and I didn't want to log in because if I do that, I'll show you later. Okay? The idea, it is a personal learning environment. We have access to different social web tools, different website, mobile learning website from which is WordPress. Here, FIP 304, which is a course I made for students in third year. They were using WordPress, and this WordPress provided them with RD attributes, okay, which are generated automatically, and Drupal, WordPress, and so on. But here we have the widget. Okay, here the widget is accessing the RDF store, and we can get the domain context. You can also have the tag cloud provided by the user. Here you have user information or user of all the different groups. Then here I can retrieve, in fact, all users recorded in the different Web 2.0 tools. Okay? And you have here the different publications made by the user. It's boring, right? Okay? Okay? Sorry. It's easier like this. Okay, and here you have all posts of the users, and we can retrieve it also. And the second website here, the second page. We made a kind of to-do list, that is to say, all activities, meta activities, which are defined by the groups of students. That is to say, they decide to have this activity to solve the problem. They distribute activities among subgroups, okay? And you can look at the different state of these activities. You can have new activities. I don't know if, new. Here, you can have a new task, okay, at the bottom of this website. Here is a to-do list for a student, but you have also the to-do list for a group, okay? And you can get all information about the course, but it is in French. And here, that point is another group, okay? The to-do list of a group. Then when you are logged in NetVive, you can see each thing. You can have, for instance, if you have to provide a report, to write a report, you can have the report as the outcome of the task, and you have it in the system. You can annotate this according to the domain ontology or with tags, okay? And then you can retrieve all these things. And because, okay, just then I can announce conclusion. Okay, just the idea is that we want to provide the user with the student and the tutors with Web 2.0 tools. We want to manage context awareness, adaptation, and to provide some activities to be in classroom, but some other activities outside. Okay, and to provide services, web services, to foster collaboration, communication, and cooperation between students. But also, we want to be able to retrieve information from the tutors. And the important thing that in future to be able to define traces and to analyze what happens during the course. Okay. But of course, to do that, we want to, I didn't use this term, but the idea behind the different widget is to make semantic mashup. Okay? But here it's very focused on each widget. And of course, in terms of technical issues, we didn't manage at present context management. And there is also an issue about distributed user model, because your user model is completely distributed on different Web 2.0 tools. Also in your RDF store, because the notion of group and the definition of different group could be in this store. And of course, a matter of ontology management and tags versus ontologies. Okay? But we didn't manage that now. Okay, thank you very much. If you have questions.
I'm curious about one slide with metadata you used, and I saw the double car. Okay, but the rest I didn't know. It says KOS and a lot.
You want to know more about that?
I don't know about what related is with learning.
Okay. What's here? Yeah, it was that.
I don't know how to.
Okay, I guess the bingo you know. Yeah? Okay. SKOS, it's a very simple ontology, like a lightweight ontology. The idea is that maybe you get a set of keywords defining the concepts, but not in terms of ontology, okay, of a domain. It's not an ontology; it's just a set of words. Maybe you have the article structure between this word, but it's not really an ontology. Then the idea of SKOS is to build the semantic structure between these keywords in order to reason, to be able to make reasoning on this. That is to say, you can say this keyword is more general than that one is more specific, and this term is a preferred term, but you can also use it, that one. Okay? Then you can, in some way, you can rebuild something like inheritance by means of these two relationships, more general or more specific. Okay? But it's not a real ontology. It's a way to simplify the process, because when you want to make a real ontology, you have to define, of course, the hierarchical structure, but also all properties inside, all relationship between the properties of your concept and the other concepts. Okay? You need to be, coherent and so on. Then you have to take lots of time. Then it's a way to simplify the process, and maybe sometimes sufficient. It depends on what you expect to do with your system.
Do you need an ontology or something like that to manage?
Okay.
Do you need an ontology or to manage all these kind of metadata? Or it's not necessary?
Of course. SKOS is an ontology. Okay? SEO says an ontology, but they are very simple.
Why don't you use long metadata?
Okay, I understand. Of course, we can use long metadata. Okay? But why? The idea is that when you are using Web 2.0 tools, okay, in fact, the database schema are not exactly the same in the different Web 2.0 tools. But to some extent, they have lots of different parts in common. But of course, this database schema are designed by different people. Then it's not the same. They didn't make that in the same way with the same term and so on. Okay. Then you have a common vocabulary here, which has been designed for that, and we can extract automatically one part of the metadata, not all the parts of the metadata. Okay. And it is very interesting because when you are using long, most of the time you have a huge amount of features that could be fulfilled automatically. Yes, but the least important one, and the most important one, you have to do it by hand, in fact. Okay? And you spend time. The idea here is to be able to retrieve automatically one path. And if people are using Web 2.0 and are putting content inside, we can retrieve the data, but of course, if you want to, okay, you send the post, okay? It's a small piece of data. Then you can get metadata, a small amount of metadata, fast. And you can reuse this content, you can manage this content. But of course, not in the same way as in LOM, okay? Because in LOM is very different, but because you want to share your learning objects with lots of different people around. Here it's a little bit different. But of course we can add, we didn't think about that now, okay? But we can add more metadata if we want to be coherent to some extent to learn. And that one, okay, is a little bit different, but these three are strongly connected. Do you have other questions?
Thank you.